Hello everyone, my name is Priyanka and I welcome you all to my session. Let's read a question. Now this question is having three parts. Let's go for it one by one. So let's discuss the first part first. It says that draw the plot of binding energy per nucleon as a function of the mass number and write two important conclusions that can be drawn regarding the nature force. All right, so I've already drawn the graph here. So we can see here that the graph is gradually increasing, that is the binding energy per nucleon is getting increased, and then it is having certain peaks here for certain atoms, that is helium and then oxygen, and then we can see that till iron that the graph is getting increased, and thereafter the binding energy per nucleon has started to decrease. So we are supposed to give two important conclusions via this graph. So the first is that the intermediate nuclei have larger values of binding energy per nucleon. See, here we can see that via the graph, the intermediate values, that is the value from here to here, we can say, is having more of binding energy per nucleon, and therefore we can say that they are more stable. And the second one is binding energy per nucleon has lower values for both the light as well as the heavy nuclei, right? They both are having lesser value, therefore they are more unstable nuclei. The next part is use this graph to explain the release of energy in both the process of nuclear fission and nuclear fusion. So, in nuclear fission reaction, unstable heavy nuclei splits into two stable intermediate nuclei, and in nuclear fusion, two unstable lighter nuclei combines to form a stable intermediate nuclei. In both process, energy liberates and stability increases. Now let's talk about the third part. Write the basic nuclear process of neutron undergoing beta decay. Why is the detection of neutrinos found very difficult? So let's write down our process first. So neutron is undergoing a beta decay. So in that process, we have a P and then we have a beta particle and then we have a neutrino. So here we can see that in a neutron undergoing beta decay, so that's the beta particle, and in that process a proton is generated and a neutrino is generated. Now it is asking why is the detection of neutrinos found very difficult, and this is because they are difficult to detect because they pass through all objects by penetrating them, that is they can just penetrate through all the objects and therefore they are very difficult to detect. So thank you so much for your time. Have a great day. Bye bye.